out what a latent profile analysis is and how to conduct one in R. So there's two types of kind of like profile analysis, like latent analysis things. There's a LPA, which is about continuous data points, and LCA, which is about categorical data points. The latent subpopulations are kind of what we're looking at here, and we're assuming that there are different attributes and profiles that we're wanting to zoom in on within this data frame. There's a certain variable, right, that helps put people in latent profiles that we do not see based on attributes. So I'm going to go ahead and load up the data. So here we are running LPA data is what we're going to call it. We're going to load that into that. Read Excel because it's an Excel file. This is where it's located. Column types, we're going to combine all these, but we're calling them each numeric because it's a numeric type of data set. And then view LPA data lets us view it. I am also using, if you realized and watched the cluster analysis videos I do, this is the same data set I'm using for the LPA. So I ran all that. These are packages I would be using. However, I already have them installed, so I have a hashtag. But if you unhashtag them, you'll see install.packages, open parenthesis, columns, and then parentheses, tidy LPA. So these are all the ones that I want to download. We are not going to run that, though. We're just going to library those packages, just because it would take a while. And this is how we're going to be naming. So I'm calling this VLPA, which is basically just my little LPA data frame that I'm creating for all the different types of classes that we could be doing. So we're going to load into that. This is LPA data because we're referring to the LPA data frame that we created right here. This symbol right here basically passes the results of one function to the next. So it's important to have, which is basically the percent sign and then greater than and percent. And then we're selecting the amount. These are the variables we want to look at. Missed days, age, years, OCP, and CWBs. And then again, this loading. For the scale, we're going to, again, rotate through all these data points. And then estimate underlying profiles. That means the amount of profiles for our latent LPA that we want. We're going to look at 1 through 5, and then this loads it. So go ahead and do all that. So now we're going to talk about validation and time. So the things we're looking at when we run these are the AIC and the BIC. So these are the most common used, like fit indexes. The smaller the values, the better the representation to an extent. So if we look down here, we've created 5 classes for us to look at. The AIC and the BIC is here, and we can see that these numbers get smaller, right, as it goes on. So smaller is better. However, this is to a degree, right? Because the best fitting model, theoretically, it would fit every single observation into a class. But that would literally just mean every single data point was a class, and we wouldn't learn anything from that. But it would be the lowest number. It'd be the best fitting theoretical model. A model with that many is not useful, though. So therefore, we're considering parsimony as we go along this way. So if the degree of AIC, BIC is decreasing very little, it's a pretty good model at that point. Typically, this is around a class of 3, but it varies on the data point. And then entropy is the amount of certainty you have. So how did I pick the one I did? We look at this AIC, BIC ones out of the ones I ran. We see, okay, they're getting smaller, but here to here is a bigger jump, 1 to 2, right? And 2 to 3 is a big jump, but 3 to 4 isn't, and 4 to 5 isn't. We look at 3 and 4, and we actually see the entropy, the certainty is a little higher in 4, which is a little odd for things like this, but it makes me want to go with class 4 because the entropy is a lot higher. It's actually a little lower, but it's not that much lower. So that's a good one to go with also because when we look at the actual models, it has the most parsimony. Like up here mentioned, parsimony needs to be kept in mind. And I'll show you what I mean. So we're going to plot these. And we can see right here in these LPAs. Right, so class 3, It's tiny, but we can see class 3 right here has like smaller groups. Class 4, there's more groups. And class 5, there's just so many groups, it's getting confusing. So even though we've got smaller numbers here in class 5 and slightly better certainty, we're also just like very confused. It's too many groups whenever I pull that up and it's bigger, and I'll show you because these are small, so it's hard to see. But because we know it's just these last 3 we're interested, we're not interested in class 1 and 2. I'm going to use the same data, the same code, not data, as I did up here, except slightly different. So all of this is the same, except we're loading into something called class 3 LPA. I'm naming it something different. And the estimate profiles is different. I'm saying I want to look at 3. That's basically meaning I just want to look at class 3 I created. And then this is pulling it up. And then this is plotting it. So we'll go ahead and look at model 3. Right here, you can see the written out data for model 3 to remind us what that BAIC entropy was. And this is what it looks like. That's a pretty good model. Honestly, if I didn't run model 4, I probably would have gone with this one. It's still pretty good and explanatory. It's got all the right numbers. Then we run model 4. Again, same thing, but we just 4 profiles, calling it class 4 LPA. Loading it up so you can see it. All right, so we got over here a little more explanation, and it's not so chaotic, right? There's a little more going on, but I can still see the distinct groups, the purple, the green, the red, the blue classes that are mentioned here. And plus we've got this part explained, which we didn't on the 3, which we can see here. These data points aren't really explained. There's a lot of them up there. So a little more parsimony going on. A little more explanation. But if we get to 5, which, yes, some of the numbers might be a little better, but if we run it, it's getting a little confusing. It's getting a little much. There's a lot of classes. We're losing parsimony, simplicity for the model's sake, and applicability that way. So we're going to go with model 4 for these reasons. So I'll flip back to that one. So we can recognize, how do we use this though? So we can recognize that there are certain types of groups in the organization. For example, we could be saying, you know what, I want to fire people that have counter work behaviors. I don't want them in my organization. There's a certain amount of counter work behaviors. I don't want them. Well, we could see here, if we're looking at that, there is very much a distinct group that does a lot of them, and that is class 3. All right, so we've got that figured out. Oh, it's class 3. They're over there doing all that stuff. We can expand this a little bit. Oop, oop. Just so we can look at it all a little more. So this class right here, this group, high in CWBs. They're kind of medium on OCBs, though. They're doing a lot of OCBs, too, which are those organizational citizenship behaviors that are actually good stuff for the organization. It's going above and beyond work, doing those nice little things like making coffee for people. So, okay, we would lose that. We would lose this group of people that do OCBs if we get rid of them, right? We would also get rid of people who've been here on the longer end of the organization. Look at that. The green group up here is that class of people. They're up there at the top. Now, they're tied with the purple class, but they're up there. They've been around. And then also the age. We're getting kind of some young people. Not the youngest, but younger people. And they're kind of in the middle for missed days. They're not the worst in absenteeism. So it's important to understand the whole picture. Like, who are we getting rid of in those groups? The people that do this, if we just fired them all, what are we missing? What also good things might we be losing? Like some of those OCBs they bring to the table. So it can kind of help you realize what each group is doing rather than just thinking we need to get rid of CWBs. Well, there's other ways they can be tied to it. This can also be used in a beneficial way, figuring out who to promote, stuff like that. For example, we can see that everyone that's older in class 1, all these people are the older people in the company. They're the oldies. And they actually haven't been around the company the longest, which is kind of interesting. You would think it'd be different. And then they're pretty low in OCBs. I don't really care. But they're also low in CWBs, so not doing those counter work behavior problems. And then they're kind of in the middle with missed days. So it's helpful, right? If we want to look at, the bad thing here is the missed days, the absenteeism. So group 4 is the biggest there, the purple one. They're in the middle with age, but they've also been in the company pretty long. and midline with OCBs and CWBs. So I think I covered 3, covered 4. I went about this word right. 1, 2. So group 2 is really high in OCBs. We can see that right here. And what else are they like? Well, they don't do a lot of CWBs. That kind of makes sense. They haven't been in the company long though. That's kind of interesting. And they're pretty young. And they don't miss a lot of days. So young people that don't miss a lot of days, barely been at the company, they love to give them organizational citizenship behavior. So that can be good in that way. If we want to know who are the people bringing all the OCBs. If we're trying to fire people, we might think, young people aren't as committed. But if we don't look at the data, we wouldn't yeah, maybe that's true. Maybe they're newer to the company, but they also bring this. And we'd be getting rid of that. So that's kind of where some of the benefit of all this comes in. I hope that explanation there makes sense. So that's we look at all these to kind of validate that we've picked the best model. We're looking at, we've got good numbers here. Do we have good entropy, certainty? Is all of that going well? Right here, we're going to look at get data. So this is basically, I put VLPA because theoretically if I want to print all of the models, so I can really talk about which is best, but you could put in any of them here. We could put class 5 LPA, class 4 LPA, whatever we're looking at. And this prints out the data if you want to use it for, more research in the future. You can put get fit. That makes extra fit indices. And get estimates. So that will show the means and standard errors of the data. So I hope this was very, very helpful. Also, I might have said latent profile analysis. I think I might have said something else at some point. But again, LPA is for latent profile analysis. Just making sure I said that correctly throughout. But yeah, so that's everything that you need to know on how to run an LPA, a latent profile analysis in R. I will see y'all another time.